Hey everyone, welcome back to STEM with Lena. I'm Lena, and today we're going to be focusing on a couple different topics, so let's get started. Like I said, welcome back or welcome to my channel, STEM with Lena. And if this is your first time here, I just wanted to say that the purpose of my channel is to encourage you as students to um, take one step forward into learning more about STEM and get more comfortable around topics like this. So today's focal point is going to be physics. And you may be wondering, what is physics? You may be asking yourself, what is physics? This is the study of physical phenomena. And what I mean by that, or an example of this, is motion of matter, energy, and force. So let's go ahead and get started. So I like to start off my videos by giving you all a kind of a breakdown of what we're going to focus on today, just so you know. So today's topics that we're going to be focusing on are the speed of light, the twin paradox, and black holes. And here I included images for you guys all to just have a picture in mind when I'm talking about these topics, because these topics can be kind of hard to understand. So on the left, we have a picture of the speed of light, or you can't really take a picture of the speed of light, but we'll get into that. In the middle is just an example of the twin paradox. And then on the right is just what you can picture as a black hole. So first we're going to be talking about the speed of light. And you may be sitting here wondering, what is the speed of light? And what is the speed? How fast does this really go? So let's move on to this. Um, so let's start by discussing who discovered the speed of light, and that will be Galileo. I don't know how many of you knew that or how many of you have heard of Galileo, but he was a physicist, an astronomer, a professor, a mathematician, and a philosopher. And the list kind of goes on when it comes to this man. So in his study, he stated that the speed of light was infinitely fast. And in the early 17th century, like I said, he believed that the speed of light was infinite. Uh, the speed of light is known as the universal constant in time, and the distance that light travels in 1 year is called a light year. So that's something fun for you guys to know, or something important for you guys to understand. And since light is made out of photons, a particle whose mass is zero, which is the definition of photon, anything heavier can't go faster than the speed of light. And then up top in the corner, I don't know if I'm in your guys' way or not, but if I am, I just tried to move myself so that you guys could see. Speed equals distance and time. And then on the bottom right, I included a picture of Galileo, so you guys have a better understanding of this old man that I'm currently talking about. So now we're going to be moving on to the twin paradox. And the twin paradox is something that may be a little bit more confusing than the speed of light. I know I briefly touched on the speed of light, but the twin paradox, I'll kind of be able to explain a little bit more, because this is going to be more of the heftier section in our video today, in our lesson, whatever you want to call it. I just try not to be super boring. So I'm going to try to keep this interesting for you guys, because I know how hard it can be learning about new topics like this, especially something that you may not be super interested in yet. So like I said, the picture on the bottom right, I included in my slides earlier. And it's just an example of what the twin paradox is. And so right now, before I start, why don't we all pause the video and discuss with your classmates, your teacher, whoever you're watching this with, what you might think the twin paradox is. Because when you hear the twin paradox, what do you think? Okay, so welcome back. If you guys paused the video, let's get into it. So I don't want you guys to be scared or intimidated by this slide. It looks like a lot, but I'm going to try my best to break it down for you all. So the theory of relativity goes hand in hand with the twin paradox. So this is an experiment that involves twin A and twin B. And for the sake of this and keeping it interesting for you guys, let's name twin A Jane, and let's name twin B Jack. So let's say that twin A is in space. So Jane is in space and Jack is on Earth. Mind you, these are twins. So since Jane is in space and she's traveling faster because she's traveling near or nearly at the speed of light, time speeds up for her. Because like we said, speed of light, nothing's faster than that, right? So on the other hand, Jack, I'm pretty sure I named him Jack. So Jack is on Earth, and time isn't going as fast for him as it's not going as fast as it is for Jane. So it's going normally, like how we are, we're aging year by year, 365 days in a year, 24 hours in a day at our regular pace. So since twin A is in space, since Jane is in space, like I said, they're traveling faster. Twin B is in one reference frame, while twin A is in two different reference frames. And this means that she is traveling away from Earth and then back to Earth. So in short, if we were to observe Jane and Jack on Earth, and Jane decides that they want to go, or that she wants to go into space in a rocket, Jane will come back only to discover that Jack has aged and he's gotten older while she's the same age. So in the top right corner, I have more of a kind of like explained version of what I just said. So twin A is traveling through space at nearly the speed of light, which means their time was moving much faster than twin B's time. This is due to the theory of relativity. And in the purple box, I just wanted to highlight that twin A, Jane, is in space, and twin B, Jack, is on Earth. And I mentioned special relativity, and I know you may be asking, what is that? So special relativity is the scientific theory my fault, concerning the relationship between space and time. So next week, we are going to be focusing on the topic of black holes. My intent was to go through black holes today with you all, but I figured the last two topics might be a bit confusing and might be a little bit too hard for you guys to take in, including black holes, because black holes itself is just a topic that I can go on and on and on about, and that anybody else who is talking about physics can go on and on and on about, because there's just so much to say, there's so much to get into, there's so much to talk about, there's so many questions. So like I said, next week we're going to dive into the topic of black holes. And I just wanted to start off by giving you guys an idea of what that is. So black holes are regions of space that are packed with so much matter that its own gravity prevents it from escaping from light. So, and then here's an image of a black hole, or when they were found on Google. So thank you all for watching. Again, this is STEM with Lena, and I'm Lena. If you have any questions, feel free to comment down below. And tune in next week for a video focusing on black holes. So till next time, thank you for watching. Don't forget to like and subscribe.